Suppose that x is a discrete random variable that takes on the values -5, -2, 1, 4, 7, and 10. If y is a good approximation for x, determine an expression in terms of y for the probability that x gives us a value greater than 1. So the best approach for something like this is to draw a mock histogram. Doesn't have to be particularly accurate, it just needs those main features of histograms. The rectangles we make need to be centered above the values that x takes on. I think we go up to 10, right? Yeah. You'll notice each of these is going up by 3, so each of the rectangles we make has a width of 3. But after that, well, it's entirely up to us how we choose to shape our histogram. So we just draw whatever we want. And you get really advanced at these, you don't even need the rectangles even. And in fact, the online notes take this approach and call this process a continuity correction, and that's fine too. So there's my mock histogram. It's got the features of a histogram, and that's all we need to sort of visually sort this out for ourselves. Now, what do we want? We want to talk about the probability that x takes on a value bigger than 1. Okay. So which values could x be? Well, it can't be -5 or -2 or 1, because those aren't bigger than 1. But 4, certainly. 7, absolutely. 10, in fact, anything bigger. If we had more, we'd shade them in as well. Okay, but we've sort of reached our limit. Okay. So now that we've got that, we need to find a way to trade it for a probability in terms of y. And we could imagine y is some sort of good approximation, so it's got a density function that sort of weaves in and out. And it's close enough. Okay? So we want to trade this blue area for this pink area. Okay? That is now under the density function for y. Right? Now, because they've said x greater than 1, we're going to give an answer that looks like y greater than something as well. I know, we could stop over here where the 10 stops, but typically we don't do that. Okay? Typically, if they give a one-sided inequality, we should give our answer as a one-sided inequality as well. Okay, so now what do we need to do? Well, we need to figure out where these areas start. That's the value that goes here. And thanks to our picture, we can see, oh, it's going to start halfway between 1 and 4. The last unshaded thing and the first shaded thing, the first of the values of x that satisfy this condition. Okay, well, what's the halfway point there? Well, 1 plus 4 divided by 2 should be 5/2, or you could write 2.5. Either or is fine. If you're looking at a multiple choice question, of course, you make your answer match the given responses. But there we go. So the probability x takes a value greater than 1 is basically the same as the probability that y takes a value greater than 2.5.